Okay, so this integral, this is going to prove to be a pretty fun integral to do. The trick is adding zero. That's something we often forget about in math, is that you could just add zero and it won't do anything. So what I mean by adding zero is I'll write this as x squared minus 25 plus 25. This doesn't change anything to the problem at all. All it allows me to do is see the fact that, look at this now, right? We have x squared minus 25, and we know that itself is x minus 5, or we go right-handed, x plus 5, right? So then when we think about x squared minus 25 plus 25, we can just jump to this then. We can jump to this fact that this is exactly equal to x minus 5, x plus 5, plus 25. And this allows us to use the linearity principle to split this into multiple integrals. So now we have this integral, which we have x squared, x minus 5, x plus 5, over x minus 5 dx, plus what? Like I said, this one is going to be the first integral, and this one's going to be the second integral. And these two integrals are equal to this integral. And that's all true because all we did is just find a different way to rewrite x squared. We didn't change anything. Can I get some credit in the comment section for my left and right-handed? I might be one of the only guys that actually got the ambi down. Okay. Nonetheless, we can see that this integral, these cancel, and in this one we can just factor it out. So now we're left with these two integrals, which is a lot simpler to do. It's x plus 5 dx plus 20. I'll factor out the 25 dx over 25. So these two integrals are a lot easier to do. And we can see that what do they become? They become x squared over 2 plus 5x plus 25 ln x minus 5. And don't forget plus c. Look at that. That is our answer. It really wasn't that bad as long as you learn the fact that a lot of times you have to add zero to make it an easier problem for yourself. So here we go. We're done.